Alright, let's go ahead and get started. Yes, let's get started. So what we are gonna do today? Let me think about what have we done last time. Okay, we did this last time. We talked about the use case. If you still remember, the whole bunch of passes, branches. What do we call that? Oh, flows. Yeah, flows. Okay, flows, branches, same thing. So remember the several part of it. First is the preconditions. You want kind of list the preconditions of the use case. If something else doesn't happen, this use case won't happen. Just it's not like every use case has to have preconditions. It's an option there. If you think that's important, include it there. And we have main flow, and under the main flow we have all those subflows, or we can see that's the alternative flows, because at some point your main flow start become some branches in there. So today we'll talk about the activity program. You will visually see how those branches are. Okay, but here in the documentation, main flow, and then at some point we can do a delete, review, print, quit, things like this, and we describe all of them, and we give an ID like S1, S2, subflow 1, subflow 2, something like that. And exception flows, exceptions. It's pretty clear. That's sometimes the error occurs, sometimes you did some operations that is unusual, so things happen, exceptions happens, and that's a flow that's representing the flow, how the exceptions happen. If you're following this flow, you'll get these exceptions. Sometimes you cannot catch all the exceptions, but just try your best to see the exception flows. If you catch all the exceptions, that means your system is pretty strong, robust. However, yeah, just try your best to capture all the exceptions. Yeah, that's the ideal situation. And an example is an invalid professor ID number is entered, or the user can re-enter the number, then or terminate the use case. That's how we deal with that exception. Yeah, and the use case diagram pretty simple. A small person there. A person can be a person, that is like a real role, and or a system, some external system that is being used. Not being used. That is like using this system. No, this current system is sending some information to some external system. So the external system is using the information from this system. Okay. And extend relations. Use relation is like the register for courses is actually depend on the logon validation. If there's no logon validation, then there will be no register for courses use case. So it's not we're not able to finish this use case without the logon. Right? That's uses, but extend is different. Extend can be like the help for register. Help for register. You can still register if there's no help, but help use case extend this register for courses use case. So two different relations here.
Which one is extend?
It's not showed here. Okay. Right.
So the login validation, is that a separate use case, or you cannot?
It's a separate use case. It can be an individual use case. You can log on, but a lot of the other use cases they require the log on, right? But log on itself can be a separate thing. Yeah, use case sequence diagram. sequence diagram is the thing that displays object interactions between the object. So from left to right, it reflects the time order, how each object is going to interact with each other, and the directions from this object. And it starts with a row, and it ends in some sort of object there. Okay, and collaboration diagram is similar. It's pretty similar to this sequence, but it displays the object interaction around the object and the links one another. Yeah. So yeah, it does not include as much as information as the sequence diagram. It only shows this directions, this processes, the object. Somehow it won't reflect if you are going to have very complex interaction between objects. I think sequence is more appropriate than this collaboration. Yeah. But this diagram is another view of the same information. When you're trying to view the same information, there are different ways to visualize them. How do you want to visualize them? It depends on the scenario you're using. Like if you want to figure out the relations, the collaborations of the objects, like which two objects they are collaborating with each other, then this collaboration diagram may be better reflect those facts. But if you are really trying to see how the sequence happen, maybe sequence diagram. How each activities happen, maybe sequence diagram. Okay, all right. So that's what we talked last time, and today we will talk about still use case, but another way. All these flows, main flows, subflows, exception flows. We are going to use that. We're going to visualize them with another diagram. It's called activity diagram. So the purpose of visualization of this model, this data, this information, is to give you a more direct way to observe the relations, to observe how the flows go through, how the whole activity goes through, so that when you have this activity in your mind, you know how the system is going to work, different paths, you will know how many functionalities are needed there. Okay, let's look at the examples so you will know them. Let's see the notations. Let's see this first. Activity diagram. Speaking of this, so we're going to have a midterm next week, right?
Really?
So, yeah, it really. So it's not gonna be very hard. This is a design class, so there's nothing you need to memorize. Okay, so don't stress out. It's gonna be open note. And you don't have to be here, you just need to do it and submit it online. It's going to be available through D2L, okay? OpenNote, but do not copy and discuss with your classmates, because I can tell it from the answer. Okay, so it's going to be some sort of system design. Well, I'm going to explain what's maybe included in the next class, Monday, okay? But they are design.
Is it like
Okay, nothing to memorize, no concepts, no.
Is it like 1 hour test kind of thing, or is it like you have more time?
More time?
No, like some of them, yeah.
Oh, we do have a time
Yes.
time constraint.
Okay.
Yeah, 90 minutes, something like that. And most of the time you won't spend 90 minutes. Okay, this is an example of the activity diagram. Let me.
Can you make it larger?
Yeah, I'm trying to do that. See, even before I explain all the notations here, you can sort of understand what's going on, right? From start to the end. Like display event, display default performance. This is a system that for a select show, it's a ticket reservation, something like that, those kind of system. This is select show. Select a show. Maybe you want to purchase a ticket, you want to make a reservation, something like that. Right from the starting point, you do something like, okay, the system display the events, display performances to you. And at some point, it has some branch there. Okay, you select cancel. Just when I see this show, okay, nothing interesting, cancel. I want to play something else. Or you display some more information, and or you do something like enter a date range to do another search and display for the select event. And then you finally make some confirmation, display confirmation, save the show, something like this. Okay, so even before I explain all the notation, you should be able to understand. So the benefit of this is it can help you have a very clear view of your system, what's going to happen in your system. And on each flow, maybe there are some exceptions there I haven't taken into consideration. You can find that by observing this activity diagram, right? Activity diagram, basically it's all the activities that happens in your system, between the system and the user do something, and the activity, the system doing some activity in reaction to the user's input, right? Okay, so pretty direct, clear view of the system. Okay. So let's see how can we make this activity system. I first look at this. Look at all these notations. Right? You find a lot of notations here. The circle, solid circle, or a circle like a target, diamond, something like that. So what does those mean? How can we use them? First, let's see this circles. Download this valid. Okay, so the same. Alright, just do it here. First, we should have an initial state. So if you're familiar with state diagram, it's similar. Every time we have a initial state, just to let you know what is the starting point of this activity diagram. The system doing this activity, what's the starting point of this whole scenario, right? So, and starting point should be connected to some sort of activity. So starting point is not activity. It's not any activity, or it's just a mark that we start from here. Okay, and it's connected to the first activity, when you enter the system. So what is the first activity? It's an open application. Okay, the very first one. You can have only one initial state, unless you are depicting nested activity. That's another story. We just assume we can have one. Okay, for now. And then the second element is the action, or the activity state, whatever you want to call it. So it represents the execution of an action on objects or by objects. That means this activity doesn't have to be adhered to any certain object. Okay, it can be some job done by a group object in collaboration with each other, right? But that's an activity. That's a more abstract concept in your system, right? Like the open application, it may include the work of a lot of objects. Like if you are using iOS, right? When you open that application, when you open an app, there's called UI control some object, and then it calls another object. Maybe you implement your own view window, something like that. But it should be more than one object, but they're doing this activity. Okay, so an activity represents the execution of a group of objects or one object. That's okay, one or more objects, and we represent an activity using a rectangle with round corners. Yeah, any action or event take place is represented using activity. Yes, it's easy to understand this. So this from the starting point, opening application is the first activity. Okay, and this arrow here is an action flow or control flow. So basically it means after this activity, where do you go for the next activity? Or are you going to some branch? So this this notation of control flow with the direction tell you all this information. So it controls also referred as paths and edges. They are used to show the transition from one to another. Yeah. So and I think you want to be aware is an activity state can have multiple incoming and outgoing action flows, right? That means maybe at some point, okay, after you have some branches, they all come to this activity. Maybe you made different arrows, arrow 1, arrow 2, arrow 3. They all come to like an activity of failure or something like that. Okay, like you don't go to the class, don't attend midterm, don't attend final. They all go to like F grade, something like that. Okay. Oh yeah, and if there's a constraint to be adhered to this transition, sometimes if you're making transition from one activity to another activity, there's a constraint there, like you have to meet that condition, certain condition. You can put it just with text on that line and arrow. Okay, like change your wallpaper, generate playlist. Cannot think of any constraints there, but we will see some example later. Okay, this diamond is pretty useful. That's basically a node and the branching. So when we need to make a decision before deciding the flow of control, we need a decision node. Okay, so usually it's like, okay, this is an example. Right. We'll input the number. If it's odd number, okay, then we have this diamond here. We want to make a decision. If it's an odd number, like yes, this is the condition, yes. Okay, then you display the number. If it's not an odd number, no, you go to the show arrow. So That's useful when you trying to go to some branch, especially when you are going to use the conditions to decide which branch are you going to. Right?
Shouldn't the condition be written within the box?
Yeah, I think we can put the condition in that condition here. But if you're doing this way, it also work. Okay, you can put it inside. That make more sense. But sometimes we want the condition is quite long. Sometimes, so you kind of want to put it on the arrow. That's the same.
Because the arrow, that's you come in arrow. So putting the condition there kind of misleading. Because when you get to the diamond block, that's where you make the decision.
Yeah, but here, okay, I understand you. So the condition, if we say the number is odd, put it there, then it's totally different. Okay, here it's sort of like a question here. So it's, yeah, it may be confusing, yes, but here, if it's question here, we know that it's a condition that we need to judge. Okay, so here we go into the branches. Activity program, activity diagram using decision node. Okay, another thing called guards. So refers to a statement written next to a decision node on an arrow, sometimes within a square brackets. So the statement must be true for the control. That's like here, let me zoom in. Here, the thing within that squared brackets, that condition should be true. Okay. If you go this direction, right, go to this edge, you can order accepted, order rejected. It's similar to this. You can say order accepted, yes, no. Kind of similar. And the fork, guess what is it? Okay, its answer is there. So it used to support concurrent activities. What does it mean by concurrent?
Happening at the same times.
Yeah. So, right, concurrently is there's no need to, there are two branches, but there's no need to select only one of them. There's no need to judge which branch I should go. So when you reach this point, you just go to two different branches, do two different things, or something like that. Like taking class, listen to teacher, play cell phone, something like that. So happen concurrently. Both parts needs to be executed in case of a fork statement. Okay. Yeah, this is a good example. Okay, so when you are trying to making coffee, you do two things. Okay, maybe something have to happen first. Okay, but sometimes you can do two things together, like eating coffee, steam milk, or you stir when you are eating coffee. You stir the cup, something that happened concurrently. So we're using this kind of fork. So one input and more than one output. It doesn't have to be two. Okay, this example is two. It can be more than one. And also the similar thing is a bar and two coming, one output. It's called join. Okay, so you join the node. Join the node. So that means two concurrent activities converging into one. Well, the important thing is this is used for two concurrent activities, not for the branches to join. Okay, if you're using the branches to join, that's another notation. But here with this bar, like the fork, okay, these two things. This two or more than one or three or four. This activities has to be happen concurrently, and then they join into one arrow, one flow. Okay. Yeah, this is making coffee. Okay, making coffee, eat coffee, steam milk. It can go to the end or it can go to another activity, drink it.
Is it still okay to represent those arrows in a straight form instead of being slanted to a point? Just like we have the two arrows coming into those two activities, and then we have those arrows carrying them in the straight form, not meeting at a point.
Oh yeah, sure. You can have something like this branch out for a lot of a bigger graph, complex activities. You do not have to like make them join immediately after happening. Okay, so it's just an example that they happen to join after that happens. Okay, but however, no matter how many branches, how many like concurrent things that's happening there, at last you will have a end point. So every system they may have an end. Right? Even you have error message, cancel, it goes to the end. Okay, at last you will still reach the end, but it can go to somewhere else, travel the world, and come back to the end. Joint only for concurrent. This may be confusing. Okay, remember that joint is only for the concurrent activities. The merge or merge event. This is the thing that what I talk about. We merge the event. They don't have to be concurrent. Okay, so when activities which are not being executed concurrently have to be merged, we use the merge notations. It's also a diamond, but with more than one input. Okay, two or more activities into one, but the output should be one. Yes. Let's see, activity into one. Yeah, if a control proceeds onto the next activity, irrespective of the path chosen. Yeah. We can have both sides executing concurrently. If they're executing concurrently, we use that joint, not joint activity. This is example. Right? Let's read this example. When we start, it's like if the number is odd. If it's odd, we add 5 multiplied by 5, display number. If it's not odd, we add 7 multiplied by 7, display the number. Then at last we so no matter it's odd or not, we at some point we join here and we add 20 to that number. Anyone know what kind of formula is this? It's an interesting question. Me neither, I don't know. It's just some formula.
So what is the difference between using the bar and that at the bottom?
The joint bar versus the
Joint bar versus that branch out. Yeah, they are same, but it's just different.
I think the difference is when it's a joint, you expect the output to come from, input to come from both those branches.
Yeah.
But in a merge, it can come from anyone.
Okay. Okay. If it's like merge, it has to be more into one, and that is one to more. Okay.
Do we still have concurrency here?
There's no concurrency here.
Concurrency.
Yeah.
I think that's where
Unless
the
you have that
difference
bar fork.
lies.
That
That's
bar.
where the difference lies. In this case, there's no concurrency. In the case of join, we have concurrency. Do you
Yeah.
have any difference?
Yeah. Okay. This is called merge.
Yes.
This is called join. It's called join.
Yes.
If it's concurrent, it's called join. If it's not, it's called merge. So swim lanes is pretty interesting. That's used to just group an activity, group some activities. Like, I'll just show you as an example. Okay, activity partition 1. It's like the yes condition. It's odd. When it is odd, you do this. This is a group, makes sense, right? This is a group of activities that happens like in a row, back to back, something like that. Okay, activity partition 2. You add 7 multiplied by 7. That's the when it's not odd number, it's even number. Okay, just use that to group a group of activities. Let's see the description here. It can be a vertical, horizontal, to add modularity to the activity diagram. It's not mandatory to use that. It's an option. More clear about it's just when you group things up, it becomes more clear. It's kind of object oriented, right? You group things, you categorize things, categorize activities. Things become more clear. Okay, this is not saying all the time, but it's a thing that it's called time event. That means on this flow, it's gonna take a lot of time. Just if your system is like time sensitive, or your system is trying to reflect the non-functional requirements, which is most of the time time sensitive. Okay, like return searching result. If Google return your result in 10 minutes, you're gonna using Bing or something else. So time event here, it's just tell you image input, image processing. Okay, it's gonna take a long time, take a while, and then it's going before it's going to the next activity or state. And this final state, in the state, just the system reaches when a particular process or activity ends, is known as a final state, end state. It's a field circle with a circle around it, a circle to represent the final state. Okay, it can have a multiple final state, but you can have one final state, everything point to the final state. Or you can just, if you're using if you have a big, very big activity program diagram, maybe it's on another page, another level. If you want to point it back and mess up the activity diagram, make it looks confusing, then you can just put another point there. Just tell people, okay, this is the end. This is flow to the end. It's gonna be the same. Logically, it's the same. But eventually, every flow should be able to reach an end. Okay, unless it's a bug there that makes things go on and on. Okay, so that's all the notations. It's not very hard. Go through again. Initial state as a circle, solid. Activities, right? The flow, the things connect, transaction between activities, right? And the decision, branch, decide which way to go, conditions put in there, and guards, similar to the decision. Fork, concurrent activities flow. And join, like concurrent activities flows joined together, which is similar to merge. Difference is joint is concurrent, merge is not concurrent, non-concurrent activities. And the swim lanes group activities together to increase maybe make it easier to read logically. Yeah, there's an example. And time events, just need to tell people and take a long time. And final state. Okay, now let's go to some real world activity diagram. Okay, let's directly read this activity diagram. Okay, so it starts from the starting point, then it directly reach a bar, a fork. Fork is concurrent. They happen at the same time, so the system first display events, and it display default performances. Okay. So it's a system that you have a whole bunch of performances, and every event has a whole bunch of performances. Okay, like Thanksgiving party, a bunch of events there, or some default events, performances, maybe featured performances that this website is doing promotion to the customers. Okay, so they display those at the same time, right? And then they kind of it's not called merge, it's called join. Okay, if it's concurrent, there's a bar that it is join. Okay, join. And then it reach another thing. What's that?
That's the fork.
No, for this one, like see my mouse?
Oh, that's decision.
No, actually the second one is a decision.
Oh,
I remember decision have one input and a whole bunch of output, right? But this one have a whole bunch of input
okay. Yeah.
and one output, so that's a merge. Yeah. this is a join connected with a merge because it merged and not some other things from the following activities. Okay, so it somehow merged and it go to this branch decision here, right? So a whole bunch of decisions. Okay. So with this squared brackets, the conditions inside there has to be true, right? So after the display, you go through here to this branch. Actually, if you go through here, okay, let me download this thing so that I can use my pen to draw on that. A line. Okay, there's another line I want. Okay, this is easier. Okay, so here it's what's that? It's a merge. Yeah, go through this merge. This merge, it doesn't really, nothing happens there if you go through the merge because it doesn't have a condition you have to judge, right? So as we go from here to the merge, let's first see is go to the user selected cancel, and maybe you go to this website for some reason it's an ad, you click it accidentally, somehow when it shows up you just cancel that. Okay, then you reach this end point, right? That's a first that's one of the branch. Okay, we should not mention this branch first. We should always talk about this normal branch. Okay, just a successful transition. Okay, so let's do it again. No. Okay, here when we reach this branch, right? And then user actually, when it display some events or display the performance, then user selected the performance here. Okay. And here, reach here. Then the system display the confirmation of that user selected performance. Okay. Then you may reserve a seat or somehow something like that over there. Then you reached. Yeah, okay. There's a display confirmation. Reach here, then you reach this branch, which wants to confirm that if you confirm the confirm your activity. Maybe it's a select a seat, reserve a seat. Then it's if you confirm that, then it's saved. Then we reach the end of it.
Question. When we come to a decision point, I thought we usually have two options. Do we have more than two options?
Yeah. Here we have yes
I'm
and
talking
no.
about the previous one, the one upper one,
Display confirmation.
This one? Yeah.
Right, you have 1, 2, 3, 4. 4 options. Right, you have 4 options there. Yeah. You have 4 branches there. Okay. So this is the normal branch. You see something you want, you select it, and the system wants a confirmation. You select yes, then it's saved. Reach the end. That's one pass. Okay. And if we go another way, like we select something, we have a confirmation. I find out, okay, I may not select the correct one. So the thing is, I select no, this is not what I want. So then I go back. No. Let me use another color. Okay, the same thing will go from here. Oh, this is not correct color. We go from here, asking questions. Yes, user, select the performance. I find that's not what I want. Then I go back here and reach here. Okay, reach this merge, and nothing happens. We go to this branch again. Here I find the correct one, and I can reach this end. Okay, that's another option. Okay. Okay, or there's a third option. Okay, just those two actually are the same because they are like user select the performance, and they do something either yes or no. They reselecting a performance and reach the end. We can count them as one. And the second is, okay, since here it display the events and display default performances. Default performance, maybe the performance being promoted. So even you are not selecting any events there, those performances are there. Like you're on eBay, Amazon, even before you are clicking any categories or searching for something, there's some product that featured there, and it's on promotion, somehow it's featured there. So that's the branch. You just click the featured performance and save the show. And then another thing is, like you go here, display the events, go through the merge, you reach the condition, then you select an event. After you select an event, the system will display the performance under that event. All right. Under that event, then you kind of go back to this merge, because when you select all the event, and it display all the performances, you are going back to here, go through this merge, you reach this branch, because at this branch is literally when you are select the performance you want. Since here, when they display the performance, you're gonna have a list of performance you can select. So here, when we reach here again, you can use the selected performance. Use a selected performance, then you reach the end, something like this. Okay. Or another way is you start here, we have those displays, and then you reach this branch. Okay, and then I'm gonna search for the performances in some certain range, so it goes to here. It goes to here, and what happened afterward is it displayed those performances, and then it go back to that branch again. It look back to the branch again. Okay. And at the branch you can do all those 4 options. Okay. And at last is some sort of exception. Like we go here, it display information, we find out it's the wrong website or something like that. I just want to go. Cancel. Alright. So basically, that's the activity of this system, right? So you do a whole bunch of things. You have a lot of branches, and it covers most of the conditions, the use cases of this system. So it covers the main flow, right? Main flows there, like select things. Or when you reach here, you have some alternative or subflows over here, right? And yeah, so this can be sort of like an exception flow. Maybe it's not. If it's just a cancel, it's a general functionality, but you can include some exceptions there. Yeah, yeah. Here, enter the date range. Yeah, you can have exceptions here, like out of range, like you are selecting the date in the future, so it will have some exceptions there, and that exception probably it will go back to here again. Okay, so you can have all those flows being visualized with this activity diagram. So it's easier. Do you think it's much more easier than reading the documentation? Right? Because visually, just look through the past, you understand the whole system. Yeah. For most of the person, this visualization should be easier than those pure text. But in some case, some person they prefer the text. I'm just saying in most of the case, we prefer visualization. All right, so that's example of activity diagram. Okay, so I think any question about activity diagram? Yes.
So the spot where two other activities get back up. So from display confirmation, it says no and goes back out to the top. Did you say that was a joint or a merge?
Which one? Like
At the top, the first branch. Yeah, right there.
this one?
Yes.
It's a merge.
It's a merge. So what is a merge? What is the definition of a merge?
A merge is you have a bunch of input. A whole bunch of input, but only one output.
But it don't have to be concurrent.
Right. It not don't have to be. It cannot be concurrent.
Okay.
If it is concurrent, it should be this bar.
Okay.
It's called join.
Okay.
This bar over here is called join. Okay. So this thing is a merge, right?
Because I thought that each time that this activity runs, there will only be one input to that spot.
One input to
There
what?
will always be one at a time. No two processes will be there at the same time.
You mean the merge?
Yes.
Right. Yeah. No, they are not concurrent, so should be reached at the same time. Well, that's in general use case. But if you think about some system, but it's not the same level. Okay, so if this if this is an object that taking all this branch in, if that object lives on some server, okay, maybe different user can have their different branch reach that part of the code maybe same time. Okay, but this is not that scenario. This is a general use case. Okay. Okay. Yeah. One thing I want you to note. Okay. Here, this is a merge, right? This is a branch decision. Okay. So the difference is one is taking all the input become one, and the other one is taking one input become a whole bunch of branches. Okay. So here, actually, we may want to do this like diamond. we take whole bunch of input. This is not that. We take a whole bunch of input, and then we have a lot of output. Yeah, kind of combine these two, right? You think that's good or not?
No.
Yeah, it's kind of confusing, right? There's no such a notation. Like formally, there's no such a notation. But yeah, maybe you can read that like, okay, it's a combination of joint and branch, which just take them together. But actually, it make a lot of mass in that diagram, so it's not recommended if you want like kind of combine those two. Okay, and there's no such notation defined in the standard. Okay, UML standard. All right, so that's the example. If you have no question to the example, let's try something. Remember the flows, the use case we made last time? This one. Okay, main flow, right? And then it reach add, delete, review, quit. And then each review has a whole bunch of exception flows. Okay, let's try to translate them into the activity diagram. Okay, let's try to do this. If you have a computer in your hand, you can read them. I cannot show all the pages at the same time. So let me do this. Okay. Okay, we will have first we will have begins with the professor log on into the registration system and enter his password. The system verifies that the password is valid. Okay. Let's just do the main flow and the subflows. Let's do, if you're interested, you can do the exception flows at home. Alright, let's find the starting point. Where is it? Oh, that's weird. We have an end point. Okay, we have start point here. And then we log on to some system. We log on right and there should be an arrow from here to here. I log on. Okay. Alright. And then what's happened into the registration system and password system. Verify that the password is valid. And from the I select the current semester or future semester. Okay. Let's assume when we log on, there is a branch. This log on may be successful or not. Yes. And then we have oh, this is a state, not an activity. Here means log on like password. Like match. There's a match between the password and the username. Okay. Then we go to the select man. Let's do this. Select semester. It's not listening to me. I want to make it bigger. Okay, fine. Okay, great. Okay, you understand that the select semester. Okay, then select semester. Professor enter a desired semester. And the system prompts to the professor to select the activities. Right, then we reach another branch. Actually, here is an like exception flow. Okay, that goes to somewhere else. I won't specify it today, but it's something. Okay. So arrow. Let's select a semester. After you select semester, then you go to the branch. This branch is actually the exception, a match, or it's an arrow. I'm not connecting this to anyone, but it's actually connecting to maybe you do redo the logon, something like that. Okay, but here you select semester, then you reach 8, delete, review, print, or quit. So you will have a whole bunch of them. 8, right? Delete. What's that? Quit. Delete, review, quit, print, quit. Review. Okay, that's fine. They are actually at the same level, so the order actually doesn't matter. It doesn't. This activity diagram, if they are like the branch, it doesn't have the order. Okay, it just the condition has to be met. Oh well. Actually, I should put those 8, delete those things as conditions instead of activity. Yeah, it may be pretty rough, but you get the idea here, okay? I'm just going to do an 8. Okay, the system displays the course on the screen, contains a field for the course name and the number. So I shouldn't do this 8. I should say display. Display the information. But the condition here is 8. Okay, the condition here is the faculty select 8. Then it goes to the activity of display info. So all this, I need to remove the delete to be a condition, create to be a condition, review to be a condition. Okay, so I'm not delete them. Just maybe make it more clear. Select delete. Okay, just 2 more minutes. 2 more minutes. All right, and okay, display the information. The professor entered the name and number of a course. And the system display a course offering. The professor selects a course offering. The system links the professor. Okay, so there's a system display course. This display the course on the screen, and enter the number of the course. System display the course offering, or enter the course. Okay, so that's a whole bunch of activities here. This select course. It's from here to here. And then the system display the course for the enter the course. Select course. System
You need an exception.
display. Yeah, that's a exception. So I'm just trying to go through a general flow. Display the course info. Right, so it flows from here to here. And then the professor select a course offering. The system link the professor to the selected course. They can actually display a whole bunch of courses, and the faculty select and then faculty system link the course. So it's just okay. There's no challenge here. I need to find a better example to show the current concurrence of stuff. Okay, then it reached the end. Something like that. I can't find the end. Okay, fine. Let's assume this is the end. It's just another circle around it, right?
Yeah.
It's weird. It should be an end there because I use this tool all the time.
First, you need
Okay.
Is it under properties?
clear stuff.
Huh?
Is it under properties for the shape?
Shape? What's that? What?
So if you look at the properties for the shape that we just threw down,
Oh,
remember that?
oh, yeah. Oh yeah, that's the final. Okay, that's awesome. Yeah, yeah, that's the final. Okay, so this is not challenge at all. Yeah, I regret using this as an example. Let's find some better example next time. But it's just how we create this thing. Like kind of let you understand activities, flows, branches, merge, or joint merge. Yeah, those things. Okay. All right, that's it for today. Thank you very much.